record the drone, so it's recording. If everybody have issues, just let us, we'll delete the footage after finish. If nobody's gonna mind, this might end up on social media. So if you can just wave and then we'll let it go away. Thank you. So I'll tell you about Feds. So we're a drone company that started about 5 years ago, almost 6 years. We were the first company to provide drone as a service, mostly for the construction industry or any GIS, geographical, information system, also for inspection. Today, obviously, we're going to focus on the GIS side of things. So what we do is exactly what we're going to talk about. So we cover the whole life cycle of a construction job. I'll go into more details, but it includes surveying and mapping, it includes inspection, it includes progress monitoring. So, as we've been operating now for about 6 years, and we're a company that started here out of the UAE. Today, we're recognized as the 7th biggest drone operator, or drone as a service company in the world. This just tells you how big this market is, in the sense of even a small city like Dubai compared to the rest of the world, how ahead we are and how fast we can grow. So, as I mentioned, drones are included in almost every cycle of the drone, pre-construction, during the construction, post-construction, and many other aspects that I want to share with you. So, before you build any site, be it a mall or a road or a railway or anything, the first level, which some of the speakers touch on today, is the earthworks, is the amount of lands that you want to move before you can start digging or start laying bases for your construction. So the first step in that one, and the fastest way to do it, is with a drone. I'll give you examples later with some pictures, just so you can get a picture. Topographic maps. After earthworks, you need a topographic map to know exactly how you want to lay your foundations. And drones can give you centimeter accuracy. Whether you choose to use photogrammetry, just like as mentioned today, or to use a laser scanner on them, both options are viable. Both options will give you a different level of accuracy. Drones before construction could be used for health and safety. So they could be used to monitor workers coming in and out, trucks, gates, just monitor basically every aspect of the construction site, just to allow. There is no need, for instance, for the health and safety manager to drive through a site to inspect everything. From his office, he have a drone that's broadcasting, giving him all the information about what's going on in the field. And site assessment is the same situation. Is everything where it's supposed to be? Is the gates closed? It's mostly related to health and safety. So traditionally, when we want to survey, we have 3 methods today that are used. We have the traditional methods that you bring in a land surveyor. He will set up a total station or a GPS or a laser scanner or whatever system. We have the planes, and obviously today we use drones. Traditional methods are a lot slower now and have a lot of limitations in the sense of timing. How much data, how much coverage you can do in one day. With the drone, you have the benefit of an airplane, but without all the cost and the expenses. So you can cover a large area and deliver data much, much faster. For those of you that don't know how a drone flying in the air carrying a normal camera can convert 2D imagery into a full map, I'll just give you a quick, basically how it's done. So usually for a large area, you're going to use a fixed wing drone. It's going to look similar to that shape, or it looks like a normal commercial airplane, only a lot smaller. So you would not use the typical multi-rotor that you're used to seeing everywhere. Mostly due to battery life. These things can fly for about an hour, 2 hours, 3 hours, which allows you for more coverage. And they're built more for mapping. So you create a flight plan for your site that you do before you reach the site. That can be done on any computer. You upload this flight plan into the drone and you launch it. The drone will follow that flight plan automatically. There's no need for an operator for that drone. Most of these systems don't even have remote control. Once they launch it, Their job is to collect data in a certain manner. And the way they do it is they will follow paths and collect data and overlay these pictures, one after the other, one after the other, and then on the way back you'll have a site lab as well, overlaying all this imagery. This data then is stored on board the drone, moved into a post-processing software. There's hundreds of them today. If you used imagery, then you use a photogrammetry software, and you can convert this data into a 2D model, 3D model, DTM, DSM, topography, extract all the details you want. And obviously from there you can act on the data the way you want to move in. Here's a table of differences. So the accuracy of a traditional survey is in the millimeters. You have static ground equipment that gives you millimeter accuracy. Again, whether you're using, depending on the device you're using, but because you're so stable on the ground, that allows you for more accuracy. A manned plane have restriction because it cannot flow low enough. So I think the lowest they can do is 10,000 feet. And from there you have about 10 centimeter GST, which allows about 10 to 30 centimeters accuracy. Drone is somewhere in between. So with drone we can control our altitude. So I can fly, let's say, at 1,000 feet, I can fly at 500 feet, 400 feet, 600, whatever altitude I want, I can control my GST. And the lower the GST, the more accuracy I can achieve. Now, if I fly too low, then I'm covering a small area, which I'm not being efficient anymore. So we need to find that sweet spot that allows the drone to be cheap and still give you good data. And we're seeing that when you fly about 100 meters or 120 meters above ground, you get about 2 to 3 to 4 centimeters accuracy, GST, which allows an accuracy in that range. So there's a sample here that says how much you can cover per day, and obviously that will relate to how many drones you're using. So one drone can do up to 20 kilometers per day. Now, how big is that drone is gonna be a huge factor in this. If the drone can only fly 20 minutes, it cannot do this. Obviously, it will do probably 2 to 3 kilometers. If you have a large drone, then you can cover larger and larger areas. And the biggest difference is in the data. So a traditional survey will give you lines. This is really what you will see. A laser scan you've seen today gives you more reality, and photogrammetry is similar to a laser scan. So this is a DSM, this is an elevation model. This is the layer of reality. So if I showed you just that bottom layer, this could be a picture from satellite, this could be just a 2D picture from the skies, from somebody flying a helicopter, but the reality is it's an actual map. This is as much of a map as it is as this is. The difference is now anybody can interpret that map, anybody can understand where the elevations are, where the water is. You don't need to be, very knowledgeable engineer to understand these maps now. So what you can do is you can present it to the owner of the site and present progress monitoring in a much easier way than traditionally done. So these are the different outputs that you can have out of a drone. Again, most of these come out of a 2D camera. You will need a multispectral sensor to produce a multispectral data. 3D point cloud can come out of LiDAR or photogrammetry. Digital surface model is a DSM, again, because every pixel on the camera, it have the X, Y, Z value, even though we'll see it in 2D, but most of this data will be in 3D. So this is a sample of construction monitoring. Again, I want to remind you that even though you're looking at it as a 2D image, this is an actual map. Everything on this map is measurable. And this is the type of progress monitoring you can see. So this is 1st of April, for instance, you have this construction site. In general, we don't know what's going on. But what we're monitoring today is the construction of this area here. They're adding a road that will be very clear when we start moving. So you can see the foundation is changing. This is a month later, and then a week later, and then 2 weeks later, and that's the completion. So you're getting a full visual of your site. So if you were the project manager and you want to oversee what's going on, this can be on the cloud. So we fly today, we upload it the next day, and you don't need to visit to monitor your site. If you were the owner for the same situation, if you were, I don't know, any authority that needs control over what's going on, if you were the civil aviation or the survey authority or whomever you are, you have access to this data that allows you to see in this much details. So again, this is not a picture, it's a map. So if you, this is zoom in on an area in this, of this map, if any of you can guess. So these guys are here. So when we zoom in, this is the level of detail you can zoom in, and obviously you can zoom in more, you can see more. And again, this is not a picture, this is a map. I can measure everything that's going on here. What the width of this manhole, the size of the scar, the width of the road, what's going on. Here's the other thing, it's also again mentioned today, volumetric calculation. Again, photogrammetry or LiDAR, it could be done both ways. The benefit of the drone is the speed. You can fly over a site without interrupting business. You can fly over a site without putting cones, without shutting down roads, without doing anything. The drone adds this extra layer of speed with millions of points as opposed to traditional survey. And I want to show you a 3D model that we need to load on. Again, I'm going to share the same details or the same data that we showed, just so you can get an idea how data looks like. So this is the same site that was there in 2D. If you can zoom out and show us the whole site, please. Or the one that didn't believe me, it's a map. Now we can measure everything. So this is a volume calculation or surface area. So basically, you can measure the width, the height of things, and you can measure the volume of stuff. So that's a pile. You put a level of points and it will produce Now we've seen 3D models. I don't know if you were here and you've seen that we put a backpack and we walk between buildings and we get that, we get the walls, we get this information. This information is great, but what about the top? What about the third layer? What's going on? So if we put the laser scanner that we saw here today on a drone, then you can get the full picture. So if it was on my back, if it was handheld, it's great. I'm getting the information of the walls, I'm getting the information of what's around me. What about the ceiling? What about the roof? What about the top? So this is what the drone brings to us as the extra layer of information that you add on top of your LiDAR, you add on top of your laser. A point of view that wasn't possible before, or it wasn't possible while being cost effective. So a lot of sites used to use helicopter before to do their progress monitoring. Nobody does that anymore, mostly to be efficient, but today every site is being monitored by a drone. Mostly for the purpose of media, but when done right, you can have all these details at this level. Thank you, Alan. That's fine. Okay, so we did the topography for the site, and we did the progress monitoring, and we did the volume calculation. Just a point on the volume calculation, you don't only measure parts, you can measure everything with this data. So it could be used for tracking your inventory. It could be a pile of garbage, it could be a pile of steel, or it could be a pile of wood. So if you are a subcontractor who's worried about theft, which was mentioned that a lot of equipment is being stolen, and it's a cost that we cannot repair. The drone data, if you have regular drone operation of your site, then you can calculate exactly when this inventory went missing. If I'm on a weekly basis doing this flight, on a weekly basis I have this data, and suddenly by the end of the site we realize that we bought 20 tons of steel but we only used 1.5, what happened? I can go back historically and check. On that week, we went from this much to this much, so clearly the issue happened that week, so it's easier to investigate, easier